Sejahtera, my name is Kimberly Edwin. I am from Group 4. Today our group will be representing about the case study, which is about the total collapse of 6 stories reinforced concrete building. We are from Group 4 and our group consists of 5 members, which are Kimberly Edwin, which is myself, Kamalling Mehui, Amira Akila binti Hasni, Nurul Hanis Hanani binti Muhammad Anwar, and also Ain Sofia Zulaika binti Abdul Rahman. So we are going to start off with the introduction of this case study. So for this case study, our team was appointed as the independent consultant to investigate the failure that occurred in the 6-story building. From our observation throughout the case, it was found that it involves a very high negligence from the owners towards the building, where they are not aware about the consequences of adding additional loadings on the building that can induce a very high amount of loading, more than what the structure can carry, and thus that contributes to the collapse of the 6-story building. So first, we are going to look at how does this happen? How does this collapse actually happens on the 6-story building? So from this case study, we already know that the total collapse was actually caused by the owner, who adds a lot of additional loadings on the building throughout the 15 years of its lifespan. So the first one is actually the 22 tons vault that was placed in the ground floor in the bank. Next one is the 50 tons of heavy-duty ceramic. And next is the 2 cooling towers that was added on the roof, and also 1 more extra cooling tower after that, which makes it 3 cooling towers on the roof. Worst things worse, a proper maintenance wasn't really practiced on the building for 15 years. So defects and cracks was actually pretty obvious on the surface of the structures in the building. Even though it's treated, it was superficially treated, which means it wasn't really treated with so much care, and the owners wasn't really paying attention to the defects that happens in the building throughout the years. And also from the observations that was made from our team, it was observed that there was actually 2 columns that contributes to the collapse of the building, which is column A and column B from the figure here. So it was actually caused by the overstress condition that was experienced by column A, and eventually it moves to column B, and thus it contributes to the collapse. And also we found out that there was actually a very poor construction practice on the concrete piles of the building, where we can actually see that the concrete piles was actually arranged haphazardly, and we found out there was actually 11 piles instead of 9 piles.
Next, the objective is to identify the key issue of the structure failure on the buildings, to suggest the most appropriate actions to improve the structural and infrastructure of the buildings, to highlight the lesson learned from the case study. So this is the objective of the case study conducted.
Hi, my name is Carmen. I'm going to present a material test in the case study. In this case study, we assume that the building will collapse due to the material test that does not carry out during the construction process or after the construction process has been done. Thus, in our group, we suggest the non-destructive test can be carried out in the building structure. This is because this test does not destroy the building structure, such as the strength of the concrete. There are 3 types of non-destructive tests can be carried out in the building structure, such as the electromagnetic cover meter, rebound hammer, and the ultrasonic pulse velocity test. For the electromagnetic cover meter, it is used to estimate the location of the shell reinforcement, main reinforcement, and the concrete cover in a reinforcement concrete. Besides, the rebound hammer is used to estimate the strength of the concrete through the rebound number. The larger average value of the rebound number, the greater the quality of the concrete obtained. At last, the ultrasonic pulse velocity test is used to determine the existence of the cracks or voids in the concrete by measuring the velocity pulse through a solid material. High velocity indicates the good quality of the material, while slow velocity may indicate the concrete with voids and cracks. Therefore, non-destructive tests plays an important role in checking the quality work of concrete so that the maintenance work can be carried out to prevent the building from collapse.
Structural analysis is to determine the effect of loads on physical structures and their components. All structures must endure loads such as buildings, bridges, aircraft, and ships are subject to this type of examination. To calculate a structure's deformations, internal forces, stresses, support reactions, accelerations, and stability, structural analysis uses applied mechanics, material science, and applied mathematics. The analysis findings are used to validate a structure's stability for usage, typically by passing physical inspections. Structural analysis is thus an important aspect of structural engineering design. There are 6 basic steps for structural analysis such that 1. Plan of structure, 2. Type of structure, 3. Applied load that includes dead load, live load, and wind load, 4. Structural analysis, 5. Structural design, and lastly, deflection. It is very important to determine all the loads we're to add it, as it can prevent the building from having excessive loads that will affect the strength and stability of the structure. In this case study, the main cause of the building to collapse is because of structure failure due to additional loading being added without concerning about the limit of structure in needing to withstand the extra loadings. For example, between 3 to 8 years after completion, cracks are already visible on walls, but no actions were taken by the owner. The columns had micro cracks as well. It then has affected the openings of the building. The reason to these cracks is because of the extra 50 tons of heavy-duty ceramic on each floor being added and the additional cooling tower. The lesson that we can take from this incident is, as an owner of a building, we should maintain well the building as it includes other people's safety and life. Always consult engineers if there seems to be problems with the building, as they can help and solve them. So based on this case study, it was found out that actually a proper maintenance was not really practiced on the building by the owners for the lifespan of 15 years. One of the main importance of maintenance is actually to ensure that the building can be operated well. Based on the observation that was made by our team, it was found out that actually defects and cracks on the structure seem to be one of the main deterioration of the building. Cracks on the surface might be the sign of distress in non-structural or structural members. It might be caused by shearing, separation of joints, excessive deflection of support, and also separation of members built with different materials. The cracks were visible in every floor of the building, and it might be located either it's on the slab or also the masonry wall or junctions of the columns. For surface cracks or non-structural cracks, elaborate measures are not required since they only appear on the surface. But by repairing it, actually render surface can be removed and the cracks in masonry can be cut and either filled with cement mortar with the ratio of 1:4, and the surface will be plastered again after that. As for heavy cracks, the wall will be considered beyond repair and usually it needs replacement. If the cracks are very obvious all over the external load-bearing wall, along with signs of settlement, the old wall has to be demolished and also rebuilt again part by part. Other than the maintenance that is needed to be done in order to minimize the amount of defects or cracks on structural members of the building, actually maintenance of the building can be done as a whole, and it should be done frequently as well, and also considered by all owners of a building to preserve the state of the building and also to ensure that it can be operated very well in the long run. So there are actually different types of maintenance that can be carried out to serve this purpose, namely corrective maintenance, routine maintenance, and also preventive maintenance.
Let's take a look at building by law. Building by law are the set of rules that developer has to abide by while developing a project. Building by law also contain rules to ensure that there is minimum harm to the environment as a result of development. Okay, based on UBBL 1984, in the structure alteration or the extension of the building, the load to which any building will be subjected, the The dead load and the imposed load, the wind load, shall be calculated, and the actual imposed load to which building will be subjected will exceed the imposed load calculation. In the according with this part, such actual load should be substituted for the load. Next, the provision stated for this part regarding the dead load and the imposed load should be applied to a new building and structural alteration and adding existing building structure and also existing constructions on the change of the use. This provision cannot be applied to the maintenance or the replacements of the parts, existing buildings and the structure where there is no change of use. The dead load shall be calculated from the unit weight given in the BS 648 or from the actual weight of the material used. Okay, based on the case study, we can see that the structure engineer has been ignored the provision stated by the UBBL 1984, and the Building Control 1989 was accredited to the Building Control Regulation 1989 that any additional load or alterations, additional installation need to be contact with the engineer in charge.
Safety and Health. Department of Occupational Safety and Health, which is the part of Ministry of Human Resource, is abbreviated as DOSH. Basically, the general responsibility of architects, engineers and also designers are outlined in the DOSH standard. Those who are responsible for the design and construction of any planned building or civil engineering works should pay a special attention to the safety of the workers and also the general public around the construction site at the planning stage. Reasons of collapse. So the main cause of the structure failure is because there were additional loads that were added to the building. After the completion of the building, the owner himself has added a total of 3 cooling towers to the roof. 22 tons of bolt was installed in the bank on the ground floor, and also a certain outside layers on each floor of the building were fixed with heavy duty ceramic that carries about a total of 50 tons of wing for architectural purposes. So due to these loads, the building cannot withstand the loads and it eventually collapsed over the time. The next one is poor construction practice and maintenance. The investigation of the piles revealed that this building has poor building practices, with a pile positioned haphazardly, which show 11 piles instead of the expected 9 piles were placed in one case, and also during the cracking stage there is no maintenance were done. Last one is precaution that should be taken. So the first one is avoid major alteration, because it is another major cause of the building collapse that are made to the basic exterior and interior arrangement of the structure. Next, check for the foundation. We have to check whether the regions receive a heavy rainfall, because we want to avoid flooding and consequent weakening of the foundation. Next, awareness of the construction area, which is in case the building is located around the swampy ground, a stronger foundation is required as compared to the solid ground. And the last one is avoid changes to the stability arrangement, as we know that we cannot simply change the structural arrangement, because to avoid the structural failure.
As a lesson learned from this case study, structure design analysis is a very important step when constructing a building. Any additional load that exceeds the allowable load may lead to the structure failure. One must take proper precaution before designing pile foundation so that the possibility of the failure reduced. The foundation of engineering also need to be applied on all aspects. Other than that, to ensure work will not compromise stabilization, a competent person should be consulted before adding or making changes to or undertaking any structural work on the structure. Any major alterations or renovation of the building must need to be consulted with the professional engineer in charge. Any unusual crack must be reported to the authority to avoid any structure failure from happening. Lastly, maintenance of the building need to be done regularly and thoroughly to avoid any bad consequence.